Good day, everyone. My name is 3Bagain from Best Math 3B, and today I will be presenting to you my geometric model in partial fulfillment of the subject M115 or abstract algebra. So, my geometric model is entitled Crystal Symmetry. My model is based on snowflakes. I use this because it reminds me of my lifelong dream of escaping the tropical weather of our country and having an opportunity to see snow or snowflakes in real life. I trust that I will in God's perfect time. Okay, so now let's talk about the labels or elements that I use for this model. And those are for front, we have, as we can see, Ilysomed. So those are the elements I use for the front moves. It's the letters Ilysomed. And now for the back moves, I used numbers 1, 4, 3, 6, 2, 5, 7, 8. Each letter or number represents a rotation transformation on these snowflakes. And next, as you can see, I defined the back twice. As it is, meaning how it is if you look at the back without rotating it, and next, after flipping it vertically to show the numbers at the back. So it will become 1, 8, 7, 6, 7, 5, 2, 6, 3, and 4, or 1, 4, 3, 6, 2, 5, 7, 8. So as we can see, we have here crystal symmetry for front and back after rotating. As we can see, I is symmetric to 1, L is symmetric to 4, Y is symmetric to 3, S is symmetric to 6, O is symmetric to 2, is symmetric to 5, E is symmetric to 7, and D is symmetric to 8. Okay, now that we know that, let's move forward with the front moves. Okay, so now let's us discuss the following moves. Starting with the front move, we have the I, it's equal to do nothing. So we will not be doing anything for I. For L, we will be turning it one to the left. So what does that mean? Okay, as we can see, we will illustrate it in the next videos, but for this one, let me explain it to you. If we turn it to the left or one turn to the left, this eye will go here because we are turning it to the left. Okay, so L will come out and L will be here. So we will talk about that the next video. So let me just discuss the front move. We have ILYSOMED for so 1, 2, 3, 4, 5, 6, and 7 turns to the left. Okay. So for the back or the moves after the back or moves of back after rotating, we have here flip vertically for 1, flip vertically, then 1 turn to the right, which is 4. And for 3, we have flip vertically, then 2 turns to the right, flip vertically, then 3 turns to the right, which is 6. And then for 4, we will be going backward. Okay, so flip vertically, then 4 turns to the left for the 2 to come out. Okay, so we will be doing it like this: 1, 2, 3, and then 4. So this 1, 2, it will be here, and so on and so forth. And as we can see, we have here all the possible moves for the front and back moves. So let's check how it will be happening. As we can see, I star I, it means I star I, we are just doing nothing. That is why, as we can see, we have here the answer I. So if we try to do it to everyone, I star L, I star Y, R star S, I star O, I star M, I star E, I star D, I star I 1, I star 4, I star 3, I star 6, I star 2, I star 5, I star 7, I star 8. It will come out the same with the letters or the elements at the head or at the first column and first row. And this will happen. Okay, that would be it. ILY SOMED14362578 and one ILY SOMED14362578. So why don't we try the I star L? As we can see, or I mean L star L. For L star L, we will be looking at L already and then move to the or from I, we will be turning it to the left or one turn to the left. That is why if we are already at L, because we are L star L, and then we rotate it one turn to the left, we will have Y. That's it. That is why L star L would be Y. And then if we will be doing the L star Y, we will have S. Because if we're looking at L, and then we will be doing the Y, two turns to the left. So from I, 1, or from L, 1, 2. That's why we have S. The same with the L star S. It's O because from L, we'll be looking at L and then moving three turns to the left, one, two, and then three. And so on. Same with O. And E because for M, we have five turns to the left. We will be counting starting from L, one, two, three, four, and then five. That's why it's E. And then for six, we have six turns to the left. That is why it's D. And lastly, for D, we'll be turning it seven turns to the left and we'll go back to I. That's why we have L star D is I. Okay, why don't we try the next one? We have here L star 1. Okay, so if we're looking at L and then we flip it vertically, the answer would be, what do you think? It's 4 because if we flip the model itself, we flip it vertically, we will be having 4 as the result of L star 1, meaning the 4 is at the back of L. And then for 4, we have here flip vertically, so we're looking already at 4 because 4 would be the new L. And then we have one turn to the right. So as we can see, we're turned here at the right side of the mm, model. We turned it clockwise, okay, because we are turning it to the right. So it will be 3 and then it will be 6 because we will turn it two turns to the right. And then for the L star 6, as we can see, 6 flip vertically, then 3 turns to the right. That is why we have 2. And then now how will we get the number 2? We will be flipping it vertically. So we're still looking at the 4 and then 4 turns to the left. Okay, so 4 turns to the left. So it would be 5. As we can see, 4. And then if 4 is here and then we turned it to the left, we will be having 1, 2, 3, and then 4. That's why we have here the 5. Because if we turn it 4 turns to the left, 5 will be the answer, and we are looking at the 4. And then 3 turns to the left, it would be 7, 8, 8 for the 7. 7 turns to the left. And then lastly, if we rotated it, the 4, we rotated it to the left. Okay, we will be having 1. If 4 is here and then we turn it to the left, 1 turn to the left or counterclockwise, we'll be having the 1. And that's it. So as we can see, if we did that to everything, or as we can see, if we tried doing all of the moves, each element will be having this table of result. And that would be okay, I don't think, or I don't know why is it so a bit laggy. And as we can see, that would be the table of result for this one. And that is everything, or all of the results after multiplying each element to another element. Okay, let's check the next one. We have here the table of result. Okay, that would be the table of results for every combination of each element from I to 8. And next we have here, or we will check if this model will have a group structure. So as we can see, a mathematical group structure is defined as a set with an operation that satisfies 5 properties or 5 conditions. So after knowing the or after completing the table using 16 symmetries, all we need to know now if this forms a group structure. Okay, so we can see here we need to satisfy 5 properties. So we have here well defined, closure, associativity, identity, and inverses. Okay, which is well defined. This table or the table shows exactly one resulting element for every combination of 2 elements. For example, we have L star Y, we have S, and O star M, we have L. There are no cases where A star B gives 2 possible outcomes. There will always be one outcome for for every combination of 2 elements. Okay, so that is well defined. Let's check. Let's check now the closed. We have here, is it well defined? Oh yeah, we already tackled about this one. Therefore, it is well defined. So next, we will be checking the question, is it closed? So as we can see, we can say that it is closed if all of combinations of elements remain within the set. Every operation result is still within the original set. As we can see, the set H is equal to the elements I, L, Y, S, O, M, E, D, 1, 4, 3, 6, 2, 5, 7, 8. This ensures the operation never produces something outside the set or undefined, meaning all of the combinations that we had, or these operation tables that we created, each cell shows the resulting of combining 2 elements. So we know that all of these elements right here came from the original set H. Okay, so therefore it is close. So yes, it is close. Now let's move forward with, is it associative? To check if it is associative, we will rotate the table to 180 degrees to see if it is symmetrical to our original table. Okay, so that is the way or how we will check if it is associative. We need to rotate it 180 degrees. So we have here the 180 degrees rotation of this original element, but as we can see, we cannot understand it yet. So the thing that we need to do is flip it that it we can see it clearly, and then after seeing it, all we need to do is interchange the rows to check if it will be associative. We have here the table that is looking correctly or properly to us, and then D rows which is placed with L row. This is the brown. So we know that IL, so the IL should be here. So we need to switch these two. And the next one that we need to switch, we have, you see we already corrected it. It's already IL, and then the D is already here. And then for the next one, the yellow, we will be rotating E rows, which is placed with Y. So ILY. So Y should be here, and then E should be here. Let's do it now. And as we can see, after doing it, we have ILY. So after doing it, as we can see, we have ILY. MOSED. So what should be the next one here? It should be S. So as we can see, we need to rotate the M and S, or the green. Okay, we need to rotate the green. We need to switch the M row, switch its place with S row because it should be ILYS and then OMED. So let's rotate it and we will have this table right here. ILYSOMED. So now the letters or the front moves or the upper part of our table is already correct. It's already the same with this one, as we can see. So the only thing that we need to correct now would be the lower part of our table. So 1 should be here, so 7 should be here. So let's correct it. We have here, but as we can see, we need to 7 rows which is placed with 1 row, which is the red one. Okay, so let's switch it. We can have here now the, so as we can see, we have here the 1 and we have here the 7. And the next one we need to switch would be the 5 row and the 4 row, which is the violet one. And as we can see, it should be 1 4, not 1 5. So let's switch it. So now that we can see here that we switched the place for the 1 4. Okay, now we need to do is switch the gray one, the 2 and 3, for us to have. So yes, would be it. 1 4 3 6 2 5 7 and 8. So now we have the correct formation for the rotation of 180-degree table and the original table. So it's clearly the same. So let's check the result of interchange. We have here ILYSOMED 1436257 8. So it is the same with the original table after flipping it 180 degrees. So is it associative? The operation table remained consistent and the same, meaning they are indeed symmetric. Therefore, there exists an associativity in the table. So after doing the interchange or after interchanging some rows, we now we can now conclude that this table or there exists an associativity in the table. So yep, associativity is check or associative is check. So next condition should be or would be, does identity element exist? So the identity is I, as we can see. When any move is combined with I, the result is the move itself. Therefore, it has an identity element. Because anything that you multiply with I, the result will always be anything that you multiplied it with, which is itself. So that is the meaning of identity element. Okay, you make or the result will always be the same with what you multiply. So therefore it has an identity element. So next thing that we need to check, does an inverse element for all exist? Each element A must have an inverse A inverse, such as that A star A inverse equal to A inverse star A is equal to I. So if we can see an I in all of the columns and rows, it means that we have an inverse element for all, because anything that you multiply with this inverse element, it should be I or should be equal with I. Okay, so I, and lastly I. So as we can see, I is really, or we can see I everywhere in this table, per row and per column. Meaning, we have here I prime is equal to I, as we can see, because I star I is equal to I. So the inverse element of I is I. L inverse equal to D. Why? Because if you check what is the element that you multiply that came or that had the result of I is D and L. That is why the inverse element of L is D. Okay, the same with y star or y inverse is equal to E, S inverse equal to M, 0 prime is equal to O, O prime is equal to O, M inverse equal to S, E inverse is equal to Y, D inverse equal to L, 1 inverse equal to 1, because the intersection of I or the two elements that has the intersection of I is 1 and 1. And then it will be the same with 4 and then 4, 3 and 3, 6 and 6, 2 and 2, 5 and 5, 7 and 7, and 8 and 8. So that would be the inverse or the same. They are in the inverse of themselves. Okay? So as we can see, therefore, it has an inverse element for all because there is an identity element for every row or column. And that is I. And that is check. It has an inverse element for all. Therefore, geometric model snowflake or the geometric model crystal symmetry I have constructed forms a group structure because the following conditions are satisfied. That would be it is well defined, it is close. There exists an associativity, it has an identity element which is I, and has an inverse element for all. And that would be it. Thank you so much for listening to my project number 1. And again, my name is 3Bagain. Thank you so much.